Hey everyone, welcome back to our YouTube channel, Becoming a ROS Developer. I'm Desire, and today we've got Jose, who has just completed the course ROS 2 Navigation. So, as we always do, we'll first begin by seeing a demonstration of his code base running on a real robot, and then we'll get into the details about how he did his presentation. We'll get to ask him a couple of questions towards the end to find out a little bit more detail. So I will hand over this platform to him so he can begin his presentation. All right,
All
Jose.
right. Okay. So we're going to start as usual by building our packages. There we go. ROS to build. Sometimes it takes a while.
All right.
There we go.
Okay, there we go.
There we go. All right. And then we always source install bash. Okay. And then what I like to do is I like to open up another terminal and open up RViz 2.
All right.
Yeah.
It's a little bit leggy, but
Just a little sorry. It's it's a bit the weather's been pretty bad recently.
yeah. Okay, there it's going now. Let's see.
Uh, just make sure I can. Okay, so I can't move it. Okay.
Okay.
I'll move it over here. Okay. Bigger right here. Okay. And let me open up our configuration.
Mm-hmm.
So right here you can see I have multiple configurations. This was the culmination of working through each section. So right here I have the configuration for making the map,
Mm-hmm.
the configuration that was updated for making the localization,
Mm-hmm.
and then finally the culmination of everything, which was just the path planning.
All
So
right.
I will be opening that one up.
Okay.
Uh, just discard this one. Okay. So as you can see, we load in because we haven't loaded the localization yet. We don't have the map, so all we see is the TF right here.
Mm-hmm.
So if we go back to our original ROS2 launch project, up that project localization, localization launch. Hi, there we go.
Mm-hmm.
Now we should be getting the map. Okay,
Okay, there
and
we go.
where was it? There should be one that, hmm, that's odd. Right here, the global status is, it doesn't have, we haven't used 2D pose estimate yet. So what we do is we just put it in this direction right here. And right here we have our particle
Mm-hmm.
cloud.
Mm-hmm. I see.
Yep. And because we use 2D pose estimate, it gave us an initial starting pose or setting pose right here.
Right.
And then what I like to do is I like to open up another terminal, and I haven't really tested if I can just do another launch, but what I like to do just to be on the safe side is just source install setup.bash
Okay.
and then launch the path planning.
Mm-hmm.
Up planning launch .py. There we go. Yep, configuring. Perfect. And then last but not least, we hold on, I have it. It's a long it was a long line of text that I sometimes forget, so I wrote it down right here. in the, yep,
Oh, okay, I see.
yeah. It's just a long, and let me, can I open up artist? Where was it? Right here. I guess, hold on, let me move all this out of the way so we can see the actual robot.
Okay.
All right, we'll write that down. And you're gonna see that it goes to, right now I'm trying to go to just corner one, which is about right here.
Mm-hmm.
But you'll see that because of the way I wrote the code, it actually goes to corner one,
Mm-hmm.
corner two, and then pedestrian, all with one. And I found out why actually through the process of making it. So now we're going.
Mm-hmm.
This just tells you the distance. You'll see it's quite uh quite inaccurate. It was supposed to go over here, and I'll explain that further on. Yep.
Oops. Hit the obstacle. Okay.
Okay. Yeah, this is because the map was oh geez, it usually actually makes it to corner two.
Right.
This is because it was made with the simulation. I couldn't every time I would try to make the map with the real robot, there would be obstacles in the way.
Mm-hmm.
So they just it looks like it's actually stuck. Okay. Um, just
Ideally,
stop right there.
it's supposed to deal with those obstacles, right? Yeah.
Yes.
Yeah.
Wait. Okay, let me
So you still
usually it's able to,
you build your map using the simulation, right?
yes, I know it's recommended to use the real robot, but there was I was having difficulties with it at first, and I was just s- stressed for time, so they recommended that I even told my professor,
Mm-hmm.
they recommended that I just use the simulation
Mm-hmm.
because it's the obstacles, these ones right here
Are
are all,
movable.
yeah,
Yeah,
they're
that's what
static.
makes it difficult. Yeah, that's what makes it difficult because
Yep.
they change every time, so your map changes. But it's understood.
Yeah.
Yes.
Right. Yep. Let's try it one more time and
All
see how it
right.
goes. But yeah, yeah, it's supposed to go further down, like right here.
Mm-hmm.
Yep. Turning. Come on. Oh, come on. Okay.
Let's see what it looks
Okay.
like in RVs, right? So that we can at
Let
least
me
give
see.
see roughly what it is
There we
thinking,
go.
right? So okay, there we go.
Let me see if I can. There we go. Okay. But actually, there we go. And
Okay,
it should go to pedestrian and then turn. Yep.
okay, long way around. Well, it made it.
Okay.
Okay, that's good.
Yep. Okay. Yep. I got to all the spots. Okay.
All right, let's try corner. What's the third one? Okay, pedestrian was the third one. There's corner one and corner two.
Yeah.
Right. Let's retry
Yeah.
corner one again.
Okay. There we go.
Okay. I need just to avoid that.
Yeah. It's supposed to go. Yeah. It's supposed to. Okay. Up.
Oops.
Come
Okay.
on.
There's something going on with that. On your map, right? Is that it looks like
Yeah.
uh,
Looks like it's actually.
it's misrepresented a little bit. Maybe just a
Yeah.
little. Yeah.
Can
Just
I zoom
enlarge
in?
that one and let's see. Yeah, it's misrepresented a little. Plus, there's
Yeah.
also the cylindrical obstacle there. But well,
Hmm.
let's do corner two, just for confirmation's sake.
You know what? Let me hold on. Sorry. Let me move it backwards so it's not
Oh,
up
okay, so
against
it's
it. Up.
yeah. I understand.
Up. I don't know why it's okay. Let's go back to our. Nope. That's not what I want. There we go. Now it's the corner two.
Mm-hmm.
Up. I hit corner one, but okay. Yeah. That's just going to corner two now,
The nice thing is it
which should
manages to
be.
avoid the obstacle. It's just that when it's trying to navigate to corner one, that's where everything goes nuts.
Mhm. And now it's going to pedestrian after corner two.
Uh huh.
That's just the way because of the way it's coded.
Okay. Okay.
and then it will turn and say, yep. So as
So,
you can tell, like,
tell me something. So, does it just passes by corner two, but it doesn't stop? Um,
let me see. I think it should have
Because
because
that's pedestrian, right? I thought it should have been in
yeah,
one of the corners. So,
I think it did. It just didn't say it went on to the next. Let me try instead of corner one. Let's just go to corner two directly.
mm-hmm.
There we go.
It's using the
Okay, well
same
that's
part,
it's
but
using corner one. Okay, that's
uh huh.
and then it does the same thing. Okay,
Okay, let's see where you've got your parameters saved. Just so. Okay, just hang on.
I have
Is
it
it still
dropped.
going?
Yeah, huh?
Okay,
That's okay. Okay, well that's at corner two.
right. And
Okay, it stopped.
it made
Huh.
it with some confusion though. So,
Yeah.
let's just see
hmm
your YAML file, right? Just to review.
Yeah. Let me see here.
No, sports YAML. Yeah, the one
Oh yeah.
there. Right.
There we go. Oh no, this right here is the one that they made us use before creating the the spot to file.
Right.
So
Right.
here we go. This is the one
I see.
that it uses.
Okay, that's the one that
Yep.
that uses a service to get the spots where the robot will be. Okay.
Yeah.
All right. I see. Okay, I've got corner two. Right. Okay, that's perfect. Okay. Let's go on.
Okay. Should I start the presentation
Yes, let's
or is
go
there
for
more?
it.
Okay.
Let's get onto the presentation now.
All right. So hello everyone. Once again, I'm Josue Valladares Jr. over here at the University of Houston. And today I'm talking about the ROS2 navigation project. In It's divided into five sections, well, really four.
Mm-hmm.
Section one is to create a map of the environment. So what you have to do is create a package named project mapping,
Mm-hmm.
and this should contain your config file, which has your cartographer.lua, and your launch file to launch the cartographer.
Mm-hmm.
Yeah, and later on nav2 map server, which is just after you've created the map, it just allows you to use the map elsewhere with the
Mm-hmm.
server. And inside of that package as well, you should have a maps folder with your Turtlebot area, YAML, and PGM files.
Mm-hmm.
And so right here, just some screenshots of the cartographer and you have to include the launch file, the config, and as maps as well
Mm-hmm.
to use them with the setup. For section two, this is the localization of the robot. This is how the robot actually knows where it is with respect to the map that you made in the environment.
Mm-hmm.
So right here, you just have, once again, a configuration folder or file, sorry, folder with your AMCL configuration, your spots, and they ask us to, in one of the sections, they ask us to write to a text file.
Mm-hmm.
I I thought that was a bit, what's the word? I don't want to sound rude. A little bit redundant
Oh,
or obsolete. So I I figure we wrote to one YAML file. Let's write to another one,
all right.
and then um, and we have for the launch file the localization which we launched in the demonstration, and then spot.launch is what actually we launch to write. I'm sorry, the launch file that we use with spot to file to get the points
Mm-hmm.
into spots version 2.yaml.
Mm-hmm. Did you pass?
And it,
Did you wait? Did you use ROS param to pass your spots to the node that's supposed to do the the path planning?
yeah, the parameters, get
Okay,
parameters.
you used that.
That's in the path planning. Yep.
Okay,
And
all
they ask us to make a, a service.
right, right.
I made a, I used a custom interface package
Right.
to write the service message.
Right.
I forget, I think it was called my message service or something like that, something specific.
Right.
That's
Okay.
just what it contained.
All right.
Yep,
Let's go on.
yep. And then RViz2 is what we use to test with the map. Right here we just have this is the this should okay, this is the localizer. That should be the I should have showed the path planning, but
Mm-hmm.
yep. Your R in the end with path planning, you're gonna your map your RViz2 will have map, TF,
Mm-hmm.
the robot model, laser scan, pose with convariance, particle cloud, and up top right here there should be a 2D nav2 goal
Mm-hmm.
around here. But you can just add that with the plus or minus.
Mm-hmm.
Yep. And then here we just have the spots to file, which is just here we just create the subscription. Here we have the service, and then here's the callback and the save callback right here, which just while you're testing it, you would go to corner one, call it, it would get the position, the orientation,
Mm-hmm.
put it into spots version 2.yaml,
Mm-hmm.
and you just do that repeatedly for corner two and pedestrian as well.
Mm-hmm. Okay. Okay.
And finally, section 3 is the path planning system. This one is you'll have by far the most files in your configuration file because to launch path planning,
Mm-hmm.
you need, I believe it's the AMCL node and the, is it the maps? I think it's the map server as well.
Mm-hmm.
But you need that before you launch path planning, which is in localization, which is why we launched localization and then path planning.
Mm-hmm. Okay.
So in that you'll have the BT navigator, your controller, your path plan, your planner, your recovery, and your behavior XML.
Mm-hmm. Okay.
Yep. And these are just screenshots of what that would look like. Just the BT navigator, controller, your behavior tree, your planner, and your recovery.
Okay. Right.
And then finally, they ask us to create a spot recorder script, which we did in section 2,
Mm-hmm.
to format the parameter. And so in this section, all I mainly did was just write the action client, which just, and then I changed the name of the spots.list YAML
Mm-hmm.
to spots version 2.yaml.
All right. Okay.
And yeah, once again, it's just the setup and then the spots.yaml. And yep, here we go. This is the main code for the action client right here. We just, it's this. So like I said, when I would launch corner one, it would go from corner one to corner two to pedestrian,
Yes.
uh, just automatically. It wouldn't stop. I'd have to retype the code with corner two. It's because of, I believe it's this line right here. This, I tried to do them one at a time and I was just unsuccessful. And then somebody recommended just try this, put them all like this, and it worked, but I could just never get it to stop at one spot, wait
Um,
for another input, and just
Yeah, well,
yeah, that's
ideally that's what you'd want it to do, right? You want it to go to the
yeah,
spot and then wait, right? So let's
and
take for
then wait,
example,
and
yeah,
then
let's take for
yeah,
example that it's going to deliver something, right? You don't want it to just pass by without delivering the parcel. So um,
right.
that's what we would want it to do. But well,
Hmm.
it does work. It's just that not exactly the
Yeah,
stuff we would have wanted. But okay, let's go on.
and part two is just the sending the goal to the next spot. This just checks if all the spots are visited, which is why at the end it said it was finished because it went through all the spots.
Mm-hmm.
Then we then it checks for the current spot name. It verifies that that spot exists, that that parameter exists. You
Mm-hmm.
can't put corner three because that doesn't exist in the spots version 2.yaml. And then it loads that position and orientation data from the spot file and then builds the navigate to pose action message.
Mm-hmm.
And that sends it to the nav2 server.
Mm-hmm. Okay.
Yep.
Okay.
Yep. And the last part is just the response, just checking if the goal is accepted. and then just giving us feedback. I added a because I noticed that it was a quite a bit what's the word? Not accurate because the map was made in the simulation,
Yeah,
not
yeah.
with the real robot.
That's
I wanted to
always, yeah.
check how far off it was. And as you saw, it was a couple meters, at least like point 0.2, 0.3 meters off.
Okay. It's good that you
But yeah.
checked. It's good that you checked. Yeah. Um,
And then, yep, that's it.
all right. All right. Okay. Very nice presentation, Jose. Now I would want to know you didn't. We didn't really see you build the map, so can you walk us through what you did in the process of building the map, or if you were going to do it right now in the real environment, how would you go about it?
So like if I wanted to build the map, so starting from the beginning.
Yes.
Okay. So what I would do is I would open up RViz 2 and I would go to actually, let me see. Is it here?
So let's
Which one?
assume you
Yep.
wanna actually build the map using the real robot environment, right? So using the robot
Yeah.
lab, yeah.
So I would open up, or I guess since I'm starting from the beginning, I would make the configuration
Mm-hmm.
to make the real map. And then since I'm already connected to the real robot where was it? It doesn't show it. Does it show it here? It does not. But anyways, I would launch RViz 2. I would have this, and then because I'm making the new map from scratch, it would have like lines of like grayed out, like it wouldn't be fully formed. I would move the robot around with the real robot
Using teleop,
going to
right?
going to like yeah.
Mm-hmm.
Or I guess you could use teleop, or since we're using the real robot, maybe the gamepad, the little circle thing. I would
Yeah.
just move it around the map. I chose to do it with the sim. I chose to do it like very slowly. I know you could go like really fast all around, but I found that there were more blurry spots that weren't filled in when I went really fast. So I decided to go slow and get as much of the map as I could,
Yeah.
just going around, getting everything.
All right.
Yep.
All right. All right. Okay, so in that process of mapping, right? What's the main sensor that you'll be relying on, and how is the map formed? Can you tell me in relation to the occupancy grid what is actually happening in the process of making a map?
Process of making the map, the occupancy grid.
Mm-hmm.
Um, I know that there are spots, I'll just call them clear spots.
Mm-hmm.
It's when it's clear that the robot has like it doesn't know what that is, it hasn't seen it yet. When they're this, I'll just call them white.
Mm-hmm.
It's represents empty space.
Mm-hmm.
And I believe the black spots right here, these represent occupied space, which is like your obstacles, your static objects.
Yes.
Yep.
All right. So you do get, you do get shades of gray that you can also use to define the probability of an obstacle being there, right? So for you, for
Hmm.
this map, it's quite simple, right? Because you can see that there
Yeah.
is total black, and then the opposite, which we in this case it's gray, but it will be white in
Hmm.
your map file, right? But
Right.
there is also the possibility of you defining areas that have got not as much black, but that are in between
Hmm.
black and white to give a probability of them being occupied. So yeah, it's your explanation got there. It's fine. So
Okay.
now, in relation to that, right? Can you
Mhm.
distinguish
Up.
for me the difference between a global cost map and a local cost map, right?
Um, am I still here? Hello? Hello?
Yes, I can hear you.
Can you hear me?
Yes.
Okay, I don't know. I disconnected. But a global cost map is sort of the map of the entire environment. That's the whole map.
Mm-hmm.
A local cost map that's what it uses to do the global cost map is what it uses to plan where it's going, like plan the trajectories,
Mm-hmm.
whereas a local cost map is used to predict, like you said, where there are objects. In the course, they actually showed us that like the global cost map is all around, but the
Right.
local cost map is like a couple of meters or doesn't cover the entire map. It's a couple meters in this case away from the robot.
Yeah, it's
And
like
that's what it uses.
the range of its sensors, right? So
Yeah,
like
pretty much.
what
Like
what
kind of
it,
like eyesight.
yes, what
Yeah.
it is seeing at that time, at that moment in time,
Mhm.
is what makes up the local cost map. So yeah, on the right track
Yeah.
right there. All right.
Okay.
One final question. Let me
hmm
just see. With regards to behaviors, right? Can you tell me
hmm
the default behaviors that your robot defaults to in case it encounters an obstacle, right? And how else can you, what tool can you use to define extra behaviors if you want to?
hmm I know the three behaviors that, to my mind, that brings up from the recovery series.
Mm-hmm.
I believe it's spin, like it spins around.
Right?
Um, what was it called? Back up, where
Mm-hmm.
like it goes back,
Mm-hmm.
and the last one. Wait, I want to say wait. It just stops right there. It
Yeah,
just
yeah,
waits.
that's the one. Yeah, that's the one. Yeah.
Yep.
All right.
And then to add more to answer the second part,
Mm-hmm.
I want to say, because if I go, where was it? Right here to the, I want to say you could add more plugins here, more behaviors here, but I
Mm-hmm.
don't know if that also follows with the behavior tree
All right.
XML.
Yeah, there's a graphical tool that you can use. It's in the courses. You can look it up.
Oh,
But yeah,
this thing.
yeah.
Yeah, this, where was it? Right here.
Nah, not that one. It's
Oh, not this one. Okay.
yeah, it's not really internal to ROS, but well, I'll leave that for you
Mhm.
to look it up. It's not internal to ROS, but you can use it to um, create or define behavior trees. But um,
Oh, I think I know
yeah,
I want to say Groot, right?
that one. Yes.
Groot. Yeah, yeah. The only reason I know I also took the behavior tree course as another project.
Yeah.
Yeah.
All right. So it benefited you. That's quite good. It's good you could link them up. So, all right,
Yep.
Jose. It's been a very nice presentation. So we'll just wrap it up here. So I think just hang on. All
Okay.
right. All right, everyone. So this was Jose's presentation. Well done to him, and would like to encourage all those of you who would like to try the courses that we offer certification on to go for it, and you can come give your presentation. So until next time, keep pushing your ROS learning. Bye bye.